Hi, welcome to our lesson on density. So before we get into exactly what density is, which we will talk about in a moment, density, it's first worth noting, is a property of matter that is determined by what the matter is, not how much you have of the material. So we have talked about intensive and extensive properties, and it's worth noting that density is intensive, okay? So remember, intensive properties don't change if you take a little bit of the substance away or if you add a little bit more of the substance. So for instance, the density of this chemical over here, which is bismuth, the density of the small pieces is the same as the density of the big pieces. All that matters is that it's bismuth. If it's bismuth, then the density is 9.78 grams per centimeter cubed. So another example, the density of 1 gram of iron would be the same as the density of 10 grams of iron. All that matters is that it is iron, and therefore it has a constant density. So again, density is an intensive property that is very likely to be on the test someday. So what is density? Well, density is a property of a substance that depends on two things: how tightly packed the atoms are and what kind of atoms they are. And what this ends up telling us is basically how much mass is in a certain amount of volume, okay? So if there is a lot of mass in a certain amount of volume, so let's say we have a substance here, and there's just a ton of atoms in that size, in that volume. If there's a ton of atoms, and maybe they're really heavy atoms, like big atoms from the bottom of the periodic table, that's going to represent a high density. Now, what if we take a similarly sized volume and there's only a few atoms in it, like that many, okay? Well, that would represent a low density because there are very few atoms in that space, okay? So again, how tightly packed they are, the more tightly packed they are, the higher the density, and what kind of atoms they are. The heavier the atoms are, the higher the density is going to be. So we have examples here of a couple different substances and how they interact with water. Hopefully from previous knowledge, you know that density determines whether an object is going to sink or float in water. And generally what we see is that low density objects rise to the top, and like the metal over here, high density objects fall to the bottom. So what we know in this cork ball here is that it has few atoms in that volume, you know, not too many atoms in there, and that the atoms are not like super duper heavy atoms. Wood is going to have its atoms tightly packed a little bit more. Atoms are probably similar because cork and wood are both going to be plant-derived substances. So probably similar types of atoms, but they're going to be closer packed together in wood. And that's why the wood will sink a little bit below the water level. And then finally, metal is going to be very tightly packed and big atoms. So tons and tons of atoms. I might not be able to draw them all the way through here, but they're bigger atoms and they are more tightly packed. They're so close together. There's like almost no empty space between them. So that's what leads metal to have such a high density, and it will cause it to sink to the bottom of the water. So a little thought experiment here. How could you change the density of a marshmallow? So it has to do with how tightly packed those marshmallow atoms are. A marshmallow is going to be mostly made up of like copper, hydrogen, oxygen. How can we change their placement? Well, number one, you can squish it. If you squish it, the atoms are going to move closer together. And what that's going to do is that's going to result in a higher density. So if you squish them together, higher density. Well, how can we do the opposite? Well, you can expand the marshmallows. You can use a vacuum chamber or maybe a microwave to expand that. It's going to cause the atoms to move farther apart. And what that's going to do is it is going to lower the density. So if you can change how closely packed those atoms are, then you can totally change the density of an object. Okay, what can we see as a result of density? So we kind of already talked about this, but objects will layer themselves in order of high density objects below low density objects. So what we see in this little, we call this a density column here, is that this heavy object down here, the key, has a high density, and that's why it falls to the bottom. This liquid here, I'm not 100% sure, but it kind of looks like syrup. Maybe honey that also has a high density. The stuff here in the middle, we would just say it has a medium density in comparison. I think that would be water. Here we have probably oil. This yellow stuff here is probably oil, and it has a lower density than water. And then finally, the rubber ducky. The rubber ducky is like mostly made of air with a little bit of rubber to hold the air in. And so that has a low density. And that's why our rubber ducky friends will float in the bathtub. They will float on top of the water because they have a low density. Okay, so the definition of density, y'all, is the amount of mass in a certain volume. So that's what density boils down to. Density is the mass found in a certain volume of an object. And so that gives us the mathematical formula for it. So density is mass over volume. This will be included on your formula sheet, but I just like to remember that I love density. And so I write a little heart next to the D because I love density so much that I send a little Cupid's arrow through it. And oh, look at that. That kind of makes it look like the formula, doesn't it? So if I go to red, I now have D for density equals M over V. Okay, if that helps you remember it, that's wonderful. If not, you'll have the formula available to you. So again, down here, density is mass over volume. Just a little reminder about the way that we measure these different terms. Density, pen, there it is. Density, well, actually, let's talk about mass first. Mass is typically going to be measured in grams or some variation of it, like maybe kilograms. Volume, you are going to see either milliliters or some sort of cubic term, like centimeters cubed, okay? So then because density is mass over volume, and so that's grams over milliliters, the density unit that you're going to see is either grams over milliliters or grams over centimeters cubed. So if I swing on back up here to bismuth, that's what we saw here. The density of bismuth was 9.78 grams per centimeter cubed. So when you see a unit like that, that number is the density. And the mass is grams, and the volume is either milliliters or centimeters cubed or something along those lines. Okay, so if density, I'll write this down at the bottom, is mass over volume, well, sometimes we're going to solve for the mass, or sometimes we're going to solve for the volume. So we need to think through the algebra to rearrange these equations. Now, y'all, this is not too complicated. I like to call this baby algebra, okay? So if density is mass over volume, how can we solve for mass? Well, that means that we want it to eventually say mass equals something. So we need to get mass by itself. Well, mass is divided by the volume. So what we can do is we can multiply both sides by volume, because algebra says whatever you do to one side, do the same to the other. But then the volume over here cancels. So we get that the mass is the density times the volume. So that's the answer here for the rearranged version for mass. Now we're going to do the same thing to solve for volume. So we start with our density formula. Density is mass over volume, okay? For this one, we need to solve for volume, but the volume is down there in the denominator, and we don't want it down there. We don't want it to be in the denominator. So first things first, we're going to get volume back up to the top by multiplying both sides by volume. So that goes away. So we have volume times density equals mass. We're halfway there. Now, to get volume by itself, we need to get rid of this density. And so we're going to divide both sides by density. The density cancels, and we get volume is mass over density. There we go. Okay. Gonna take a brief moment to show you basically what I like to call Mrs. Hammer's favorite math trick. Okay. Again, we were dealing with density as mass over volume, It is very, very common that you're going to be solving for this term in the bottom. And so Mrs. Hammer's favorite math trick is that you can swap what's down on the bottom, the V, with whatever's on the other side of the equal sign, like literally just swap them. So I'm going to draw a little switcheroo arrow to show you what I'm talking about, and then write what happens when you switch it. Volume is mass over density. That's the formula that we just wrote down, okay? So it's a little bit easier to get to it if you remember Mrs. Hammer's favorite trick. If you have that V in the bottom, you're going to swap it with whatever's on the other side of the arrow. Okay. Let's get back to it. All right, y'all. So we are going to solve a couple of density problems now. How to solve these problems. Number one, when you're working with density problems, or really any mathematical formula that we will do a lot of this year, you're going to use the following steps. Step one, write the correct formula, okay? If you skip this step where you're writing the correct formula, you're just not going to be focused in on what to do. And so it just helps you kind of be prepared. Next, you're going to substitute the values, the correct values with the correct units with it. So if like the mass was 22 grams, you don't want to leave behind the V for grams. You want to keep that. And then finally, work the problem with your calculator and give the answer with the correct number of sig figs and the right units. Okay, so we're going to work through 3 problems together. So here we go. Focus in, lock in. Let's do it. Number 1, what is the density of a piece of wood that has a mass of 35.99 grams and a volume of 45.68 centimeters cubed? Okay, so I like to first kind of go through and label that the mass. This is the volume. The question is what is the density? So D equals question mark. Okay, so we are solving for density. So step 1 is to write the formula. Density is mass over volume. Awesome, y'all. Step 2 is to substitute in what you know. Well, we don't know the density, but we do know the mass is 35.99 grams. Remember, don't leave that grams behind. And the volume is 45.68 centimeters cubed. Don't leave that centimeters cubed behind. All right, y'all, we made it to the point where we are ready to calculate. So I'm going to pull out my handy dandy calculator and we're going to type this in. So 35.99 divided by 45.68. And whoa, we get this long, crazy number. Now, if you remember, we practiced this earlier. If you have all those digits, it's too many, and we can't include them all in our final answer. So we are going to, here's my pen. We're going to think about those numbers, 0.7878721 dot, 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 dot. Let's think through the sig figs, y'all. I'm going to think through the sig figs with some little notes in green. So this top number had 4 sig figs, and this bottom number also had 4 sig figs. So that tells me my answer cannot have more than 4 sig figs. So I'm underlining the 4 sig figs I want to keep in my answer, and then I'm going to put my little stop line. Remember, we have to stop it there. So my final answer is going to be 0.787. It's going to round up to 9 because the 7 after the stop line rounded up to 8. Okay, and then the final consideration is the units. Okay, well, we had grams over centimeters cubed. Nothing special happens with that, so we just leave it as is. So my unit for density is grams over centimeters cubed. And we did it, y'all. That is our first example of solving for density with proper sig figs, with units. We're just doing it as exact as we can. Great job. Let's try number 2. What is the density of a block of marble that occupies 310 centimeters cubed and has a mass of 853 grams? Okay, let's kind of think through this again. This is what I love to do to get myself organized. Density is my question mark. I don't know it. Okay, y'all, let's think through this. This doesn't really say what this number 310 is. So it's 310 centimeters cubed. Okay, what does that unit mean? And then it also says that it occupies. Well, occupies is a space thing. So I think that this must be the volume. Okay, And finally, it has a mass of 853 grams. Love it. So we're just going to label that M. Okay, so this turns out to be just like our last example. So the density is what we don't know, so we're going to write our formula. Density is mass over volume. Now we'll plug in our numbers with the units. The mass is 300 and, no, it's not, Miss Hammer. It's 853 grams. And the volume on bottom is 310. Now they wrote it with a decimal, so I should probably keep that. Centimeters cubed. Okay, so now let's do the math. Whoa. Okay, 853 divided by 310, decimal. Okay, again, we get a big long number. I'm going to write down that big long number and then we'll round it off to the right number of sig figs. So the numerical answer is 2.751612 ... Keeps going. Whoa. Okay, let's talk about sig figs in a different color. I'll go to maroon. Okay, so we're dividing. So number of sig figs, that's got 3. That's got 3. So I want 3 sig figs in my answer. 1, 2, 3. Stop. I kind of covered up the 1 there. There's the 1 there. All right, so my final answer is 2.75 grams per centimeter cubed. That is the density of that block of marble. Okay, y'all. We're going to do one more, and don't tune out. Don't think you got it all, because this last example does have something different that happens, okay? The picture here is a big clue about what's about to happen. Okay, so problem 3 here says, a metal cylinder is placed into a graduated cylinder with 24 milliliters of water. So our starting value here is 24 milliliters. After the cylinder is added, the volume of water rises to 30.4. So now it's up at 30.4. Interesting. The density of the cylinder is known to be 8.9 grams per milliliter. So I'm going to put a little P by that, label it density. And the question is, what is the mass? So I'm going to write myself a note, mass equals question mark. Well, since we know the density and we're looking for the mass, the other missing piece of information is the volume. We need to think through this, okay? Well, just like you learned in earlier science classes, this process over here is called water displacement. And however much the water goes up by, that's the volume of the object. We're going to subtract to find that difference. So 30.4 minus 24.0, if you pull out a calculator and do that, it's pretty easy, gives you 6.4 milliliters, okay? So 6.4 milliliters is the volume of that cylinder of metal. It's like this little blob thing at the bottom of the water. It caused the water to go up by 6.4 milliliters, so that's the volume of the object. Okay, so we're going to remember that that number there is the volume. The rest of this stuff, not going to think about it anymore. All right, y'all, so what's our formula? Mass equals density times volume. We solved for that earlier. So the mass is the density, 8.9 grams per milliliter, times the volume we said was 6.4 milliliters. Okay, let's get our little calculator going. We've got 8.9 times 6.4. All right, 56.96. I'm going to remember that, 56.96, and write that down. 56.96, okay. Let's talk through sig figs, and then we'll look at the units. I'll do sig figs in blue this time. All right. When we multiplied these numbers, this number had 2 sig figs, this number had 2 sig figs, so I want to keep 2 sig figs in my answer and then stop. So 56.96 is going to round to 57. And my final consideration here, y'all, 57 what? 57 people, 57 milliliters, 57 meters, who knows? We need to look at the units, all right? So in our units, milliliters were on bottom and top, and they cancel, and that leaves us with grams. Well, that makes sense because y'all, how did we say earlier that we measure the mass of an object? With grams. So this particular case is grams. Awesome, y'all. So our answer is 57. Okay. Your homework will be assigned by your teacher, and it will give you the opportunity to practice this. Just remember the density formulas to use. You've either got density as mass over volume, or mass is density times volume, or volume is density times mass. And just make sure that you are showing your work and being careful, because that is the best way to make sure you don't make a mistake. And we always want you to get the right answer. So if you have any questions, come see us. We're happy to help. Otherwise, have a great day. Hope this was helpful. Bye.